Good morning student. Today we start our new topic direct and bending stress. The subject of structure analysis 1. These are the contents of our topic: column, example of column, dam, retaining wall, chimney, example of chimney. First we know about the column. What is the column? Axial load. When the load is acting along the longitudinal axis of the column, it produces compressive stress in the column. It's called axial load. Eccentric load. A load whose line of action does not coincide with the axis of the column. It produces direct and bending stress in the column. It's called eccentric load. Eccentricity E. The horizontal distance between the longitudinal axis of a column and the line of action of load in an axially loaded column, that time E is equal to 0, it's called eccentricity. Effect of axial and eccentric load on column. We can see this figure. So there is the column, load P acting on the axis of the column. So direct stress is a similar on all direction, and it's a sigma 0 is equal to P by A. In second phase we can see, so external force P acting beyond the axis, that time direct stress will be changed. We can see in this figure, it is the combined direct and bending stress. It is the first one, A is the only direct stress, axial load produce the direct stress only. When the short column is subjected to axial compressive force, only direct stress sigma 0 is produced in the column. So direct stress sigma 0 is equal to P by A. Eccentric load produce both direct stress sigma 0 and the bending stress sigma B in the column. So that time direct stress sigma 0 is equal to P by A and bending stress sigma B is equal to M by Z is equal to M, Z is equal to I by Y. That time we can write M upon I into Y. Maximum and minimum stresses. When the column is subjected to eccentric load, the edge of column towards the eccentricity will be subjected to maximum stress sigma max, and the opposite edge will be subjected to maximum stress. That time we can see maximum stress sigma max, minimum stress sigma minimum. So sigma max is equal to direct stress vata bending stress. So sigma 0 plus sigma B, that time we can write P by A plus M by Z. So is equal to P by A in bracket 1 minus sigma E upon B. Minimum, sigma minimum, so sigma 0 minus sigma B. So is equal to P by A minus M by Z. So is equal to P by A 1 minus sigma E divided by B. Stress distribution in the column. Stress distributed in the column as the load P moves from center of column to edge of column shown in figure. So first figure, we can see the force P is directly acting on the axis. That time sigma minimum is equal to sigma max. In second figure, P moves beyond the axis. That time sigma minimum decrease, sigma maximum increase. When the different stage go ahead, that time sigma minimum will become a minus and sigma maximum become a positive. Limit of eccentricity, it's equal to E limit. The maximum distance of load from the center of column such that the load acts within this distance, there is no tension in the column. The maximum distance is called the limit of eccentricity, where the load is acting within a limit. That time sigma minimum will be compressive, so it is positive. When the load is acting on a point of E limit, that time sigma minimum will be 0. When the load acting beyond E limit, that time sigma minimum will be tensile, so it is negative. First we study the example of direct and bending stress. A column of T section shown in figure subjected to load of 100 kN at the point on the centroid axis 40 mm below the centroid axis XX. Calculate the maximum stress induced in the section. So first we analyze which data given in the example. So first force P, it is 100 kN. 40 mm below the centroid axis about axis. So E, our eccentricity is equal to 40. Part 1, A1. A1 is equal to 200 multiply with the 20 and Y1 is equal to 180 plus 10. So it is the 190 mm. Part 2, A2 is equal to 180 multiply with the thickness 15 mm. And Y2 is equal to 90. So in the example Y is equal to, we can identify it. So that after we can identify Ixs1 is equal to Ig plus A square, Ixs2 is equal to Ig plus A square. Finally we got the total Ixx. So we got the moment of inertia, that after Zxs is equal to Ixs upon Y max. So we can identify the Zxs. Dams and retaining wall. So we can see the figure of dam. The figure of dam, we indicate the so many symbols. Capital H is equal to total height of the dam. Small h is equal to water level of the dam. B is equal to base width. Small a is equal to top width. D is equal to distance from the CG2 axis about AB. Sigma h, it is the pressure on the dam. Water pressure top to bottom, it will be decrease, it will be increase. So on the top it is 0 and at the base it is maximum W into H. Weight of dam. Weight of is equal to cross section area of dam multiply with the density of the dam material. So we have the equation W is equal to A plus B multiply H by 2 multiply with the delta, where the delta is equal to density of material which is measured in kilonewton per meter cube. Total weight water pressure on dam. Total water pressure is equal to area of water pressure diagram. So P is equal to 1 by 2 W into H multiply with H. So we can see in this figure P force is acting. So WH is equal to base, vertical is a small h. About the Pythagoras rule, we can write 1 by 2 WH into multiply with the H. So P is equal to WH square by 2. Where W is equal to density of water, so it is 1000 kg per meter cube. We can write 10 kilonewton per meter cube. Next one is eccentricity. So we have to identify the eccentricity of the dam. The water pressure act horizontally at the height h by 3 from the base of dam. Total weight of W act vertically downward. R is the resultant of P and W. So we can write R is equal to under root of P square plus W square. Resultant R cut the base at the point. Distance JK is equal to P by W multiply with H by 3. So distance AJ is equal to A square plus AB plus B square upon 3A plus B. So D is equal to AJ plus JK. Eccentricity E is equal to D minus B by 2. Maximum and minimum pressure. Maximum pressure at the dam, sigma max is equal to W by B 1 plus sigma E upon B, and minimum pressure is equal to W by B 1 minus sigma E divided by B. Next one is retaining wall. So retaining wall is a similar structure like a dam. In the dam, it can fill up by water, and retaining wall usually fill up by the soil or earth. The retaining wall is a structure is used to retain soil, earth. The basic difference between the dam retaining wall is that a dam retain water subjected to water pressure, while the retaining wall retain earth subjected to earth pressure. Total earth pressure acting on the retaining wall is equal to Ws square divided by 2 multiply with the Ka. Ka is the active earth pressure coefficient, which equation is 1 minus sin phi upon 1 plus sin phi, where phi is equal to angle of soil. So P is equal to, we can write Ws square by 2 multiply with the 1 minus sin phi divided by 1 plus sin phi. Total earth pressure P act at a height h by 3 from the base of the retaining wall. Next one topic is chimney. Chimney and wall subjected to wind pressure. So we can see this figure, wind pressure kilonewton per meter square acting on the wall. H is the elevation, so that time sigma minimum and sigma maximum stress is produced in this figure. Consider a chimney or wall having the plane dimension B by D and height h. Delta is equal to unit weight of a chimney or wall. So delta is equal to total weight divided by volume. So delta is equal to W by V. So W is equal to, we can write delta multiply with V. So W is equal to delta multiply with area multiply with H. A is the base area. So direct stress sigma 0 is equal to W by A. So sigma 0 is equal to delta multiply with the A multiply with the H divided by A. So sigma 0 multiply with the delta into H. If there is a uniform horizontal wind pressure P acting on a side of width B, wind force P is equal to P multiply with the B multiply with the H. So this force will induce a bending moment on the base. So M is equal to P multiply with the H by 2. Bending stress calculate on the base due to moment. So we can write sigma B is equal to M by Z. The extreme stress on the base are sigma max is equal to sigma 0 plus sigma B, and sigma minimum is equal to sigma 0 minus sigma B. First we study the example. A masonry wall 5 meter height, if of soil rectangular section 3 meter wide and 1 meter thick. A horizontal wind pressure of 1.2 kN per meter square act on the 3 meter side. Find the maximum and minimum stress induced on the base if unit weight of masonry is 22.4 kN per meter cube. So first we write up the given data. Delta is equal to 22.4 kN per meter cube. S is equal to 5 meter, B is equal to 3 meter, P is equal to 1.2 kN per meter square. So sigma 0 is equal to delta into H. We know the equation. So 112 kN per meter square. So M is equal to P multiply with the H by 2. So P is our total wind force. So identified for P, P multiply with the B multiply with the H. So we got the 18 kN. Then after we got the M, Then after we got the z, it is bd square by 6. Sigma b is equal to m by z. Then after we know the equation, sigma max is equal to sigma 0 plus sigma b, and sigma minimum is equal to sigma 0 minus sigma b. This is our chapter direct and bending stress. If you got any question, then find out from theory and equation. Thank you.